Okay, so here's what we're going to do to go get this thing. Somewhere between 98 and 97. Now notice what happened. When I lower beta, this comes down. If I go too far, I've got to go back up. Let's just do a very simple procedure to do this. So I'm going to start off with beta is 99 again. And I'm going to define a thing called d beta. Now, d beta is going to be my steps of beta I'm going to start with. I'm going to start with 99, go to 98, 96. I'm just going to keep, that's how I'm going to start off taking steps. And what do I want to do with this? Let's bring this in here. So first of all, I'm going to have to do a loop here, right? For end. I have to have a loop here. And what I'm going to do is keep changing the beta value, right? Started with 99, 98, 97, go up a little, and I've got to figure out how to lock in on the right value. But I have to have a loop to do this. So this will be for j equals 1 to like 1,000. I want to do a loop. And what am I going to do in this loop? Well, what I'm going to do in this loop is say, okay, I'm going to go look for the solution. Okay, so let's come in here, and let's ask what we're going to do. I'm going to have some if statements here. Here's what the if statement is going to say. Look, I'm looking for this thing to be 0. If, let's see if you can handle that. Okay, y and 1. What does that mean? I go to the first column, which is supposed to, and the end is the last component. So this is the solution at all the way at the end. And it's supposed to be 0. So I ask the following question. If this thing here, which is supposed to be 0, is actually greater than 0, what do I got to do? I got to lower my beta, right? So let's say beta is equal to beta minus d beta. Is that cool? I just start lowering it. Else, so there's another option. So if y is bigger than 0, I mean, so it's above the line. I have to take my beta smaller. But if it's lower than 0, I have to go back up, don't I? Because I overstepped. So I'm going to do the following. Here's just one possibility. I'm going to do the following. Beta is equal to beta plus d beta. Here's one possibility to do it. So I go back to where I was. But what I really got to do now is say d beta is equal to d beta over 2. What did I just do? I cut my step in half, right? In fact, I only have to go halfway back up. So let's talk about this. This is an important step. So I'm taking steps of 1. I go 98, 99, 98, 97. Too far. Let's go back to 97 and a half. In other words, just bisected it. But now, when I take a step, I can't take steps of 1 anymore. I've cut my d betas in half, so this is what I got to do. Now I can take steps of a half. Okay? So this is the algorithm, basic algorithm to go search for this thing. Does that make sense? Bisection. Yes, that's the next thing we're going to do. So this is how you would step. By the way, if I don't do anything and I don't break it, it's going to go through this thing 1,000 times. We have all time for the world here. We got 10 minutes. 1,000 times actually takes a very short amount of time. Okay? But that's what's called being stupid. What you want to do is you always want to think, okay, what I should do is make this be as efficient and fast as possible, which means, right, that what I really want to do is say, once I get the solution to the tolerance I like, what was my tolerance, 10 to the minus 4? I should stop this thing. All right, so, and in fact, I should stop it before I go do this extra business here, and I just say, look, if the absolute value of y end 1 less than tall, remember I had tall up there as 10 to the minus 4? Break. The break command gets you out of that loop. Okay? That's it. I know, pretty sweet, right? Pretty sweet. You thinking it's pretty sweet? I'm thinking it's pretty sweet right now. All right. Maybe it's too early for you to think it's sweet. Okay. Let's run this. Who thinks it's going to run the first time?
Hold on, you're missing an N.
Oh, what?
You're missing an N for your for loop.
Okay.
That's for your if statement.
Oh, yeah, I forgot. Okay, fine. If you want to be technical. All right, there we go. Okay, let's check it out. Now, what I want to do is I want to do a couple things for diagnostic purposes. I want it to, let's just tell it what the beta value is and what j is. I have it spit out to the screen so that we can, when we run this thing, it's going to work beautifully. We'll see how it went through the beta values. Ready? 1, 2, 3. Ready? 1, 2. Yeah, that's a good one right there. Thank you. Ready?
Wouldn't you want that after 4 loops?
Doesn't matter. Either way. Ready, 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 ready? Ready? All right, wait, there we go. Dang. Oot, oot. Okay, there we go. We got that solution. Look at that. It goes off from 0, and it lands at 0 from -1 to 1. Now, that was pretty fast. Let's actually see how it actually did that process. So we can go back here to the screen and see what got written up here. All right, so we have to go up here a little bit. And look at this. It's so nice that I put all that information out. When beta started, it was 99, and j was 1. And then beta went to 98. Then it went to 97. Then it went to 97.5, as advertised in my little example I gave. Then 97.75, blah, 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 blah. And it starts to converge. Starts going, till finally beta. You can do this. Format, long, E, beta. There is the value of beta, 16 decimal places. And it took 18 iterations to get it. Okay? So just went, locked it in. By the way, would anybody have guessed that nice, sweet number right there? I don't think so. Okay, so this is good. So we got a solution. We know how to get it. Now, here's something else about this problem. Let's take it out of the loop for a moment. I know we did all this work, but that's okay. You just do like that, and you just so text, comment. Boom, look at that. Dang, rock. See, that's nice, yeah? I'll comment that one out too, and I'll comment this out. Oh, sorry. Comment that out. Okay, now we're back to where we were before, right? No loop, nothing, just this thing. We started at 99. I know it was 97 point something. I'm going to do the following. Remember, when I said, let me just keep playing around with beta. Let's look at 96. This keeps going down. See that? It's down here, all the way at -0.1. Oh yeah, let's make a back to 1 again. Let's go 95. 95. Let's go 94. We're just playing around. We don't really know. We're exploring the equation right now. Whoa. Someone's turning. You see that? I'm going to drop and drop, and all of a sudden, boom, wants to go back up there. It loves that spot up here. And this is a little bit of a problem and a challenge for you, perhaps, because you don't just have one solution. In fact, if we go close to around 93, you run 93, starting to come up. Let's go down all the way to 90, for instance. Well, look at that. That's pretty close to a solution, isn't it? Okay, so you remember how I wrote the beta n in class last time? So you see why I did that. Because there's actually there's more than one solution here. Now, I might say to you then, give me the first 5. We've got 5 minutes to do it. MacGyver action. MacGyver could do it in 5 minutes. In fact, I'm just going to stall here, talk a little bit, because I could do it totally.